Alright class, today we're just going to move around the log function, the graph of a log function. If you remember correctly, the parent function of a log is goes through the point 1, 0 right here, has a vertical asymptote at x equals 0, and then starts down there and goes through that and it kind of goes up. Now you can use this for all bases. We're going to just care about that one point and the vertical asymptote. So really what you have to worry about is the vertical asymptote only moves if there's a left or right shift. And the point moves if there's a left or right shift or an up and down shift. And you have to remember that you're starting at x of 1 for the point. So let's look at a couple transformations. So this one you should note that the only transformation here is left 2, which means that my vertical asymptote is moving 2 to the left right here. And I know the point started at 1, 0, so after the transformation the point is now at negative 1, 0. So there's my point. And that's the graph pretty much. You just have to then sketch a graph going through those points. And I will say the vertical asymptote is x equals negative 2. And my point that I'm at is there. Because we care about the one point and the vertical asymptote. So here we have two transformations. The first one is right 5. The second one is up 1. So if I start the point at 1, 0 like I'm supposed to, if I move right 5, it is now at 6, 0 after the first transformation. After the second transformation, if I move it up 1, it's at 6, 1. Also, the vertical asymptote moves right 5, so the vertical asymptote is at x equals 5. So here's the vertical asymptote at x equals 5. The point is at 6, 1 because it got moved up. And then it's the same sketch though pretty much. So there's that one. Number 3, we're going to add another transformation. This time we're going to, well, first we're going to do this one first because you always do the horizontal shift and then compress. So this would be right 4. Then we have a vertical expansion by 2. Which means you multiply the y by 2. Okay? And then finally we move it up 1. So right away I know the vertical asymptote is going to be at x equals 4. That's fine. So we know that for the graph. Then for my point, I start at 1, 0. If I move it right 4, I'm now at 5, 0. If I expand it, the y, multiply the y by 2, we're still at 5, 0. That doesn't stretch that point. And then finally, the third spot where the point is, we're going up 1, we're at 5, 1. So I have a vertical asymptote at x equals 4. I have a point at 5, 1. And it is more stretched, so you can exaggerate that if you want. But other than that, I really just care about the vertical asymptote and the point. Alright, the last one. The first thing that happens is it's a reflect with respect to the x-axis. And to do that, remember you multiply the y by negative 1. So multiply y by negative 1. Okay. And then the second one is up 2. So what's nice about this is the vertical asymptote did not move because there was no left or right shift. The point starts at 1, 0. The reflection doesn't do anything to that point. So then the final thing moves it up 2. So we're at 1, 2. So I'm at 1, 2. And because it was reflected, the whole graph was reflected, you have to draw the graph starting from up here and curving down this way. So that one was reflected over the x-axis. Okay, so that's all I'm looking for these. No calculator, pretty easy. So these we're supposed to solve without a calculator, although letter B gave us some big numbers. Remember, when you have a log that you're trying to solve and you can't figure out what it is here, rewrite it into exponential form. Remember, this is your exponent. This is your base. So it's saying 3 squared equals x. So x equals 9. Here, our exponent is 7, so 3 to the 7th equals 3x minus 2. Again, you're not supposed to know these numbers off the top of your head because they're kind of big. So you should end up with an x of 2189 over 3. Okay. Now, this, for some reason, lost the e here. Remember, natural log is the same thing as base e. So I'm going to rewrite it as log base e of e to the x equals 5. So if you're not sure, I know some of you guys remember the property from honors or from algebra 2 trig that these should cross out, the x comes out. We haven't done those in this class yet. So the other way to think about it is rewrite it like we did the other ones. The base is e, the exponent is 5. That's going to equal e to the x. The bases are equal, so that means x equals 5. Here we're going to rewrite it the other way. The exponent is negative 2x plus 1. That's going to equal log of base e 13. So if I rewrite that in the correct form, log base e is natural log of 13. And now I solve. Negative 2x is equal to natural log of 13 minus 1. Do not subtract 13 minus 1. Those don't go together. In fact, if you're afraid you're going to do that, just put parentheses around natural log of 13 because it's a number. And then x is equal to natural log of 13 minus 1 all over negative 2. And that would be the exact answer without using your calculator. Alright, so I cannot stress enough for the quiz, you need to be very comfortable switching between the two forms. Exponential form and log form. Okay, also know your shifts and the parent function of that graph, and also your exponential graph. And that's all. Nice short video.